and how far we've come in the past 30 years with free software. Outstanding. This is about a 15-minute chat about free software and how far we've come in Unix-like operating systems in honor of the Free Software Foundation's 30th anniversary. I'm Beth Lynn, president of the Ohio LInuxFest, and I will willfully admit the only computer that I had in my household was a Nintendo in 1985. I feel quite fortunate to be inheriting a great legacy of Unix-like operating systems and free software and everything that's entailed over the past 30 years. So I've asked my dear friend John Maddog Hall, who has worked in the industry of proprietary and free software through about 30 years ago. Where were you 30 years ago?
Let's see, 30 years ago was 1985, and I was at Digital Equipment Corporation working on a commercial version of Unix. We had been supporting Unix for a number of years because Unix was first developed on DEC equipment, first the PDP-7, then the PDP-11. And Digital Equipment Corporation was supporting it from the fact that we had a lot of orders from the telephone company, we had a lot of orders from universities, and they wanted to have Unix working on their systems, and they needed to have hardware support. So we would, use some of our engineers to write a few device drivers so we could sell them some hardware. And we would repair the hardware and sell hardware contracts. And about this time, there was, and I can also use this as an opportunity to say that Unix was never free, okay? Unix was kind of open only from the fact that Ken Thompson would take around his little tape to various universities and give it away, and all of the lawyers back at AT&T would wince. And so there was no license with this or anything. He would just hand a tape over, and they would start to use it and share it with other people. And several years later, after he started doing this, the lawyers caught up with him and said, no, this is really Bell Laboratories' property, and you have to stop doing this. And so if you were a research university like Columbia or Berkeley or something like that, you could get Linux, or you could get Unix, I'm sorry if I'm saying Linux, you get Unix by paying a relatively low license. I think it was $350. And that gave you the right to run Unix on any of the systems that you had. And it was distributed in source code form. But the problem was, if you were not a research university, for example, if you were a small two-year technical college, like I worked in from 1980 to 1983, I'm sorry, 1977 to 1980, you had to pay $160,000 US for your first CPU. And that got you the source code license to put Unix on one CPU. You wanted to put it on two CPUs, it was another $160,000 US. And then three was another $160,000. And that's because it was a telephone company and they didn't really understand quantity discounts. That wasn't even the worst part. The worst part was that you also had to tell them the serial number of your CPU. So how many of you know the serial number offhand, the serial number of your laptop or anything like that, Well, it wasn't much better back then. And if you wanted to take it from one CPU to another, say one CPU broke down, you wanted to take it and put it on a CPU that was working, you had to call up AT&T and tell them the serial number of that machine you were going to put it on. Now, this was obviously not the way that's to sell operating systems. And there was this little company called Sun Microsystems that had gotten a single board computer built based on a Motorola chip from Stanford University. And this was a pretty powerful little system. And compared to the days of that day, it was relatively low cost. And they were looking for an operating system. And they went to a lot of people. They thought about CPM, but CPM was really not powerful enough for this board. And they actually came to Digital and tried to license VMS. And Ken Olson said, well, no, I'm not going to do that, because we're going to have this on the VAX. And that probably saved Sun Microsystems, because if they tried to put VMS on there, it would have taken them years. They would have gone out of business. And eventually they went to Berkeley and said, hey, and Bill Joy became part of Sun and said, hey, why don't we put Berkeley UNIX on there?
Bill Joy was in the last film. How
Exactly.
do you feel about that?
Exactly. Well, how do I feel about it? Well, he was a good project leader of that time back at Berkeley, and he did a lot of work in creating the visual part of VI, okay, the text editor. The EX part already existed. He did the quote graphical part. But it is kind of quote graphical, okay. But in any case, he did that, and he worked a lot on particularly the VM of the system. So now there were two different Unix systems. There was system 3, 4, and 5 that came from Bell Laboratories, and they were kind of a swapping type of system and things like that. And then there was BSD Unix that came from Berkeley. Is there a question or comment in the back? Because you still needed to have a license, even if you were using Berkeley Unix. Okay. I'm getting to that. Okay. So what happened was Sun Microsystems had to come up with a business model that made sense, that you didn't have to pay $160,000 for the software that was going to go on your $20,000 machine. And they came up with a concept of creating a binary-only license. That if you had a binary-only license, and by the way, there were two of them. There was a two-user license. If you only had to have one person on the system, you'd buy a two-user license. Why two-user license with one person on the system? That's because another thing had to be there, and that thing was root. You had to be able to have root there, so you could then have a regular user too, in order for the Unix system to run. And then you had a, quote, multi-user license, or unlimited. You could put as many people on that particular machine as it would take with hardware, as much as the hardware would stand. And the multi-user license was $350. But most importantly, you did not have to know the serial number, okay? And so Sun Microsystems worked out this deal with AT&T, and they started to produce these workstations. And the workstations were, by those days, so cheap, so inexpensive, that people were starting to buy them. And at that point, other companies like Digital, like IBM, like Hewlett-Packard went to AT&T and said, we'd like to have the same deal. And the AT&T lawyers would rumble, and then the lawyers back and forth would rumble and stuff. And eventually they all formed more or less the same deal, that they could distribute binary copies of Unix for a much lower license price than a source code copy. But if you were an end user source code, if you were a person who needed the source code, you first had to get an AT&T source code license. Then you went to the company that sold you your Unix system. Then you got a source code license from them, and then you got the source code itself. So this could run you well into the $200,000, $300,000 marketplace. Now, of course, this tended to lap over to other things. So, for example, at certain universities, like MIT, who did have a source code license and could get the source code for their Unix system, they had to pay for the extra source code if they got their machine from Sun, or if they got their machine because they were no longer distributing their operating system in source code form. And so that's where these people, and even at the University of California, Berkeley, it was interesting. They were talking about Berkeley there. I went there one time as a representative of DEC, and they had purchased our operating system called Ultrix. And the people at Berkeley never had a kind word to say about Ultrix. Okay, they said, "Oh, it's so old. It's got it's terrible. It's terrible." But I went there, and all of the academic computers were running Ultrix. And I says, "Well, wait a minute. You're Berkeley. Why aren't you running Berkeley?" "Oh, we are running Berkeley. That's in the research division. But we're the academic division. We're the ones. We're running the systems for the average student." "Well, why are you running Ultrix?" "Well, because Ultrix stays up. The research software keeps crashing because it's research software. We expect it to crash." So there you can see what happened. And the people who were using the academic Ultrix version typically had only the binaries, not the source code. So there's a little bit of background there. And before 1986, most software was delivered in source code form. But because I'm sorry, 1986. Because there wasn't enough market of any one type of computer to justify getting a binary distribution out. It was actually with the advent of the PC that and CPM and those type of operating systems, the binary software really came in. Before that time, a lot of people distributed their software in source code form, or you had bulletin boards that you would go out to and get your source code down from that, type it into the computer, and have it work.
A little over 30 years ago, Richard Stallman was at MIT, one of the academic institutions that you had mentioned, and it's my understanding that it was actually Carnegie Mellon where he had his epic meltdown concerning a certain printer driver that was not disclosed. Now, you talked a little bit about how source code was assumed to be openly shared amongst academic institutions, but not for everybody. Now, that's something that I'm actually seeing in my field at the University of Chicago, where my current day job is, to this day, where people will claim that the license is open source. However, it is only given gratis opportunities to academic institutions. Can you talk about why is it important for software to be free and to be free for everyone?
The real beneficiary of open source software is actually the end user. And if you have a computer system that you've had for 5 years or 6 years, a piece of hardware, and maybe you bought it and you had some closed source operating system on it, and now it's 6 years later, the hardware is working perfectly fine, but that company is no longer supporting that particular operating system. Now you have a choice. Either go to the new version of the operating system, and maybe that doesn't work as well as the old version did. Maybe it requires too much memory for your old computer system. Maybe something's going on, and you can't use it anymore. This is a problem. You have to throw it out. Maybe the licensing is so restrictive that if you want to give away your old machine, you can't give it away with the software that's on it. You have to force the person to buy a new piece of software that's really expensive in order for them to be able to use the secondhand machine. And sure, you can ignore the license. You can say, okay, I'm just going to give it to them and let them use it, and that's illegal. But it's bad when you're trying to donate it to an organization that's a nonprofit. They have to be legal, and all of a sudden they gain this machine, and all of a sudden they realize they have to spend money to make this machine that's been given to them useful. There's a whole series of things. It's the end user who really benefits from free software. I worked for Digital. We had the operating system called Ultrix. We had retired the operating system. We were no longer supporting it. And the Morris Worm came out. And the Morris Worm was a really bad worm, as kind of like a virus, and it was attacking every Unix system. And it took my company 2 weeks to generate the patch for our current operating system, Digital Unix. And I went to my management and I said, I have a whole series of people that's still using Ultrix machines. What are we going to do for them? And they said, nothing, because we're not supporting it anymore. And I almost got fired that day because I basically had to threaten them with blackmail if they didn't send somebody out there to generate a patch for Ultrix. So that took another 3 weeks. In the meantime, the systems were crashing. In the same time frame, the free and open source community, when they recognized what the problem was, had generated a source code patch in 3 hours. Put it up on the web. So no matter what version of Linux you had, no matter what architecture it was on, you could patch that system. 7 weeks, 3 hours. That was the difference.
We have a chart up on the screen here. It is from the Unix history Wikipedia. The Ultrix that you mention is TAN for the fact that it was considered a mixed shared source, meaning that some people were allowed to have the source and others were not. The pink are the completely closed proprietary software, and the green is the free software, with GNU Linux maintaining their own branch there based on the kernel. The kernel is documented there at 3x. Now, if we were to go ahead and do a similar chart of all the GNU Linux distributions, you might argue that we are just as fragmented, just as difficult to play around between vendor to vendor. Isn't there anything that we could possibly learn from the past of having so many proprietary, so many ambiguous closed source relationships? Can you please speak to this?
Well, first of all, I don't think that in the Linux space we're anywhere near as fragmented as those were. Because, as I said, there was originally 2 completely separate trees of code. One was the AT&T System 3, System 4, and so forth up to System 5, and then the Berkeley code, completely different kernels. System 5 was a swapping kernel. Berkeley was a demand page virtual memory kernel. Berkeley developed TCP/IP. System 5 was still UUCP for a long time. And they were just completely separate. And even when Sun Microsystems made their choice to go from Sun OS, that was Berkeley-based system, over to System 5, yes, they took the System 5 interfaces, the System 5 APIs, but they completely dragged out all the System 5 code and rewrote that with code that they had improved based on their experience with Sun OS. This is why it took them over 2 years from the time that they announced that they were going to do this to the time they actually delivered their first product, which was immediately termed Solaris. And I mean, and there's nothing against Sun or the engineers that were there, but they had taken an operating system they've been tuning for 2 or 3, for 10 years, and basically exchanged it for something else. And of course, over time, Solaris became much faster, much better, much more tuned again. Well, let's see.
What year was the change for the recording?
2.1, and that was what year?
93, it looks like, according to the chart.
Well, yeah, but that was 2.1 to 9. Solaris 1.0 came out, yeah, 2.1 was back in 1990, 1991.
Okay.
So up until that time, you had Sun OS, which is based on BSD. Sun OS over there, see it? Sun OS was from 1981 up to there. Oops. And the same thing happened with digital Unix. We went from Ultrix, which was a Berkeley BSD-based kernel, over to DEC OSF1, which was an OSF1 microkernel-based system. Now, why did we do that? Well, a couple reasons. The Berkeley kernel was built kind of like what we call the spaghetti model. Okay, we had a centerpiece of code, and they kept coding out. And then you had outer layers that actually used the inner layers, and inner layers that used the outer layers. And so after a while, you couldn't change anything inside the system without completely destabilizing the kernel. It became very, very difficult to maintain it. OSF1 was a much more structured kernel. It was kind of like a microkernel on the inside. And so we took it as a structured device. Plus, on the Solaris side, there was a little bit of political thing where they could say they are AT&T UNIX, System 5, the right choice. And on the OSF1 side, you had IBM, Hewlett-Packard, and Digital supporting another standard that was called OSF1. And so there was some politics in there that was pushing this back and forth, which now we come back to Beth Lynn's question, how is Linux better than that? Well, Linux is better than that because for the most part, people are using the same kernel on all the different distributions. And when they make changes to it, they've learned to upstream those changes back to the kernel organization. They found out that when they don't upstream those changes, that they have to apply those changes to the next version of the kernel that's coming out the day after tomorrow, or the day after that. And that's a lot of work and a lot of expense. And why should they do that? Because people do not buy the computer system because of the kernel that's on it. They buy the computer system because it's solving a problem that they have to solve. And so in these days, the thing that's, for the most part, what you're buying the computer for is to get your application that works or your phone that works. That's what you want.
One last question, which I actually had planned to pick on Bill Joy of the last film one last time. So he gives two separate quotes. One's to say that the platform will always be popular amongst engineers due to the portability of the source code. However, for the rest of us, not so much, to paraphrase. Not without, again, to paraphrase in 2015 terms, a killer app. What about GNU Linux? Was Apache that killer app to make the operating system to be suitable for business? Is it Android? Is it something else in the future?
Well, and I'm going to have to, because I'm sure there's a lot of people out there who have lots of ideas about this, and I would welcome the opportunity to talk about that, particularly at the speakers dinner, which is coming up next. But my belief is that some amazing things happened at a particular time. If there was such a thing as grace and a guiding being, that these things happened with Linux. because quite frankly, a lot of the Unix vendors had given up on Unix. They were still supporting it. They had ceded the desktop to Microsoft. That was gone. And all the interfaces that people would humanly use were ceded to Microsoft. And if you remember, the O'Reilly books were written with all the animals coming out about Unix. But all of a sudden, there were books from O'Reilly talking about Windows NT and Windows and Microsoft because Tim O'Reilly, the sole functioning savior of free software, had recognized that the way he was going to keep his books in business was to sell Microsoft books. But then Linux came out, and all of a sudden the tide began to turn again, and O'Reilly started writing more and more stuff about Linux. So what were those things that happened? Number one, here's an operating system. It has no applications. What do you do with it? Well, all of a sudden you have this thing called the World Wide Web. And people are using Solaris systems on Spark to have server systems to power the web servers. And they found out that you could have this cheap Intel box with this free operating system that would do exactly the same thing. There was a 30% cost savings by using an Intel-based system with Linux on it. But more importantly, if you were an internet service provider and somebody was hacking into your systems or you had a problem, you could fix it yourself. And you didn't have to wait for Microsoft or Digital or Solaris or Sun or anybody else to fix it. And if you reported it to the community, you typically got it fixed back in a relatively short period of time because it was also affecting thousands of other people. So this was one thing that shot Linux forward. Another thing, it was useful on old hardware. Because up until this point, the 386 was the first processor who really was useful with Linux because it had demand page virtual memory. 286s, 186s did not have that feature. But Linux was able to utilize that. But the 386s, when they first came out, were still too expensive for people to use as a hobby to make an operating system. So if you move forward a little bit until the 486s come out, so that the 386s are somewhat older, now you have a machine that you can put Linux on and use it for something useful, even though the main operating system you're using is still Windows or something else. So these are some of the reasons why Linux started to grab exactly at that point. What was another major thing that happened? The death of supercomputer companies. Sounds strange, doesn't it? But all supercomputer laboratories, you don't go and you don't buy your supercomputer software on the shelf. You don't go down to Toys R Us or the PC store and buy your supercomputer software from there. All the supercomputer applications are typically handwritten and actually compiled on the supercomputer. They're used to doing that. But when ECL and Cray started to go out of business, all of a sudden these two guys, Dr. Thomas Sterling and Donald Becker, came up with the idea of Beowulf systems. And all of a sudden, Linux sprang into the mainstream because they needed an operating system that was inexpensive, stable. Why inexpensive? Because we needed 1,000 copies of it. You can't have it costing, $20 a copy. That's $20,000. That pays for an intern. You don't do that. And it was flexible, and they had the source code. And so Linux leapt into the marketplace again. A couple years later, what happens again? Embedded systems, years of 2000. At that point, most embedded systems are proprietary, closed source, written by each company. But now all of a sudden, something horrible happened. People realized the embedded systems had to talk to each other. It means they need a network stack. Network stacks are hard. Very hard. And they were starting to come out with all these different processors, not just Intel, but Motorola, MIPS, ARM, all these, the compilers. Hey, there was already an operating system that ran on all these chips. There was already an operating system that had a stack. There was already an operating system that's multitasking and secure, and it was free. And so Linux became, in 2 years, became the most used operating system in new embedded system designs. Literally overnight. Why did they say commercial, you never received commercial use? Because most of the Unix systems back then were used for scientific engineering type of stuff. But by the time Linux came around, a lot of the Unix systems were being used for commercial work. 86% of all of the money that flows out of computer science comes from commercial work. Only 16% is scientific engineering. And this is why most companies want to do commercial systems. Now we're going into consumerism. And here is another great thing that happened. You know, Google picked the Linux kernel to be the center of Android. And when I heard that, I said, thank God. Because this was going to be the thing that was going to drive the device driver creation for the Linux system. And when you create a device driver for Android with a little modification, it goes very well into the GNU Linux system. And so more and more people are creating device drivers that allow us to have Linux run better and better on the desktop. So these are some of the things that changed.
Thank you very much, Maddog. We have to wrap it up now. Very, very insightful discussion indeed. We will perhaps continue the discussion with you if you are coming with us to the keynote dinner. If not, will you be at the after party?
The after party tomorrow?
Yes.
Yes, I will be, yeah.
Yes, the after party is also a birthday party for the Free Software Foundation 30th anniversary. We will be serving cake. We have a pretty nice bar set up, and we also will have a video stream to the Boston party with what I understand to be a very important announcement from the Free Software Foundation's founder, Richard Stallman. Thanks for joining us at the Ohio LInuxFest. And I want to very much say, Free Software Foundation, happy birthday.
Happy birthday.